Okay, so this is what we discussed in the last class. I have to explain the coefficient of variation. So 100 R square, so 100 R square gives you the percentage dependency of the response variable in the explanatory variable. Right. So when we interpret, we don't put it this way. So we say if it is 97.2, then 97.2% of the variation in Y can be explained through the variation in X. Right? Okay. So now today we'll move on to the next part, regression. Simple regression analysis. Right? So using correlation, we identify whether there is a relationship. If the correlation tells you that there is a relationship, your next question is, okay, that's what that relationship is. So that is answered through regression. So simple regression analysis. So we have two things, simple regression analysis, multiple regression analysis, right? So first we move for this. Simple regression analysis. Simple regression analysis. Right. So in simple regression analysis, what we do is when we have one predictor variable and one response variable, we use simple regression analysis. Right? Say for example, price depends on, say profit depends on price. So price is the predictor variable, profit is the response variable. So there we have one predictor variable and one response variable. Then we use simple regression. Multiple regression we use when we have one dependent variable, one response variable, and many predictor variables. Right? Then we use multiple regression. So similarly, we can have many predictor variables, many response variables. Okay, so clear. Right? So in that case, we go for structural model. Okay. So we have to take heading. So underneath we can take down this bit. Here we try to identify. Then move down. Here we try to identify or find a relation, linear relation. Here we try to find a linear relation. Here we try to find a linear relation between the explanatory variable x, between the explanatory variable x, and the response variable y, and the response variable y in the form variable y in the form y equals beta naught plus beta 1 x plus epsilon. Beta, we write like this. Beta. Yes, right here. Beta. Beta naught. Beta 1. Right? Beta naught. And this is epsilon. Right. So there is another one like this. This is not what we have here. Here we have this one. So this is epsilon. Epsilon. Some used to say epsilon. Right? Epsilon. Zero. Okay. So now, also after that I'll explain that part. Where beta naught and beta 1 are constants to be determined. Where beta naught and beta 1 are constants to be determined. Constants to be determined. constants to be determined. So we will be given a data set. So using that data set, we need to get this beta naught and beta 1. So for that, we need formula. So we'll see how the formula we develop. Okay, so now here we have y equals beta naught plus beta 1x plus epsilon. So forget about that epsilon part. So our model is y equals beta naught plus beta 1x plus the error term. Forget about the error term. Now we'll recall the general equation of a straight line. General equation of a straight line. So general equation of a straight line is y equals mx plus c. So m is the slope or gradient, and the c is the intercept. Intercept means where it cuts the y-axis. Right. So now forget about this part. Now consider this portion. Y equals beta naught, beta 1 and plus beta 1x, and that y equals mx plus c. So when you compare this and that, do you feel any difference? Y equals beta naught plus beta 1x, y equals mx plus c. They are the same, but we are using different notations there. So y equals mx plus c. So instead of m, we are using beta 1. Instead of c, we are using beta naught. So if this is straight line, this is also a straight line, right? So we will be given a data set. We will be given a data set. So data points will be something like this. So for this data set, we try to identify a straight line for that data set. That's what we are going to do, right? So data set given. So we try to identify a line which evenly distribute these points. Okay, right. So then comes to this, we come to this error E. Now, this line is represented by y equals beta naught plus beta 1x. Now the data points, if you take, the data points will be 1 point maybe here, 1 point maybe there, like this. Right? Some point may be on the line, some point may be above the line, some points may be below the line. So now, if you take the actual y value, so this is the actual y value. So actual y is this much. Out of that, this part is covered by this model. Right? So the model covers this portion. So between the actual point and this model, there is a gap, which is called the error term, which is called the error. So that error is covered by this epsilon. Okay. So now if you take this point is on the line. This point is on the line. So actual y value is this. Actual y value is this. Model value is also the same. So actual y value and the model value are the same. So in that case, the error term is 0. No error. Right. So if the point is above the line, error is positive because you have to add some part to come to the actual point. If the actual point is below the line, this is your model value up to here. This is the error term. So in that case, error is negative. So the gap between the model value and the actual value is covered by this epsilon. So that epsilon is there for the error term. So that epsilon stands for the error term. Epsilon is for the error. Okay. Right. So now we'll see. Oh, that's model. Okay, so this is the model value. This is the actual value. There is a gap between the model value and the actual value. So that gap is covered by this error term. So if you take this one, this point, so that is actual. I'll just simply write, and this part is the model value, and this portion represents the error. So if it is on the line, erase it. Okay, so the model y represents the actual value. So that's why we take it as plus epsilon beta not beta on model value plus epsilon. Sometimes error may be positive, sometimes error may be. So in the models, y represents the actual value. Okay. So here I have put at two places just to show you. If this is the case, epsilon is the error, epsilon is positive. This is the case, epsilon is negative. One more case is there. If it is on the line, epsilon is zero. And that part I didn't write. But so now in this model, you know all the terms. Y is actual, This represents the model level part, and this represents the error part. So now developing the regression model means developing this equation. So developing this equation means what? We have to find out this beta naught and beta 1 from the formula data given, right? So we need formula to get these two. So before going into that, we need some preliminary things. So we'll discuss that and we'll go. So now we'll say, so forget about this model and everything. So suppose you have some data, x values, y values given. Okay. So no need to write, so just try to get the things. Say when x equals 2, y is 5. When x equals 3, y is 8. When x equals 1.5, y is 6. Okay, we have data set. Say we have 3 pieces, right? Now we have developed the model, right? So this is not the correct model. I'm just writing a model, right? So now say for this data set, we have developed the model y equals 5 plus, right? Plus epsilon is there. For the time being, we just forget that, right? 5 and 2 are not the correct values, right? Say for this data, then this is the model we assume, right? So now I'm going to apply these values to this model, right? What is the y value? 5. What is the x value? 5 plus 2 times 2. Then I'm applying the second value. Y is 8. 5 plus 2 times 3. I'm applying the third one. 6. 5 plus 2 times 1.5. Okay, so 3 values I have. Now I'm going to add this. So now what are these? These are the y values. So I'm going to add all these. So if I add all these, what I get in the notation form, right? So it's 14, 19. I'm not asking that. Notation form, what you get? You have y's, you have added. Using the sigma notation, what you get is sigma y. So here you get sigma y, right? So now what is this? This is the constant. 5 is a constant. Now, since there were 3 points here, we have 3 5s. So if we add all these 3, value-wise, what we get? 3 times the constant, 5, right? Okay. So now suppose you have beta naught. Beta naught. Beta naught here. Then what you get here? If there are 3 pieces, then it will be 3 beta naught. Now we are going for the generalized model. So suppose now you have n values, then what you get? N beta naught. Now here you have constant, this plus, this plus, this plus, this plus, whatever the number. Everywhere you have a 2 in common. You can pull that out. Okay, 2 comes out. Then what? What are these? These are the x's. So you have to add all the x's. So what you get? 2 times sigma x. 2 times sigma x. Now we go for the general model. What we have here? Beta 1. So if we add all these, suppose there are n pieces. So what you do, this beta naught is constant. So you take that, sorry, beta 1 is constant, you take that out. Rest of the part will be beta 1. Okay, right. So now sigma y, when the data set is given, can we get this beta sigma y? Yes, we can get. We add everything, we get sigma y. Right. Then n means number of pairs. How many pairs we have? That one we can get if we have the data set, say 5 pieces, then n is 5. Right. Beta naught unknown, we have to find. Beta 1 unknown, we have to find. Sigma x X values are there. We can get X. So we can get this, we can get N, we can get this sigma X. So we get the equation in terms of beta naught and beta 1. We want to find beta naught and beta 1. So now we have one equation, right? How? By adding as it is. Okay? Sigma Y, then general model example, Y equals beta naught plus beta 1 X. Sigma Y, N beta naught, a constant there will be N coming in, right? N beta naught, beta 1 comes out, sigma X. One equation we have. So two unknowns are there. So we need another equation, right? So to get the second equation, what we do is, to get the second equation, model we have is Y equals beta naught plus beta 1 X. Multiply the entire equation by a X. Multiply the entire equation by a X because X's are known. What we get? XY, beta naught X, beta 1 X square. Now sum it up. Add karanga then sigma XY, beta naught X. So beta naught comes out, sigma X. Beta 1 comes out, sigma X square. Okay? Idea, right? This one can be find, yes. X's are there, Y's are there, XY product, some we can find. Sigma X, we can find. Sigma X squared, yeah, X is there, we can find X squared, we can add, yes. So two unknowns, two equations. So you have a system of simultaneous equations, right? So you can solve, get your beta naught and beta 1. Okay? Right. So we'll write down. To get the note down, to get the formula, to get the formula for beta naught and beta 1, to get the formula for beta naught and beta 1, we get the normal equations. We get the normal equation. So that's how we call those equations. Two equations we call as normal equations, right? We get the normal equations, right? But how do we get the first one? Y equals beta naught plus beta 1 X. So as it is, we sum it up, right? As it is, we sum it up. So as it is, if we sum up, then what we get? Sigma Y equal, if it's just a constant, so there will be N beta naught plus. Here beta 1 constant comes out, what happens clinical, right? That's why I explained you with that example. Beta 1 sigma. Okay. So now in this one, this is known. This is unknown. This is unknown, this is known. So usually we write the known one and then the unknown one. That's how we write. Okay. Right. Sigma Y. Right. We just change the side. N beta naught plus sigma X beta 1 equals sigma Y. Okay, N is known, beta 1 not is unknown. Sigma X is known, beta 1 is unknown. Sigma Y. AX plus BY equals C4. This is one normal equation. One equation. Then the other one, how do we get? Other one, we multiply by x, then sum it up. The one, what we have the second one, y equals beta naught plus beta 1x. So you multiply by x, so y equals beta naught x plus beta 1x squared. Now we sum it up. So now when we sum it up, we get sigma xy equals beta naught comes out, sigma x plus beta 1 comes out, sigma I used to write this way, right? That sigma is the normal sigma, right? So normal sigma. I used to write like this. I will go to it. I mean, that's how right? Normal sigma, right? Okay. So here also we rearrange. This is known, so we'll put this first. This is known, we put this first, and we'll just change the sign. I'll write there. Space is not there. So it's sigma x beta naught plus sigma x squared beta 1 equals, it was in that right here, sigma x squared. Right, you better write in one line. So this is the other equation. So we need two unknowns to be evaluated. We have so this and this are the normal equation for a simple regression model. Okay. So now we have to get this beta naught and beta 1, we have to solve this system of simultaneous equation. So we don't do it manually. We can use the calculator and get the answer at once. Okay. Do you know how to get that? Can you use the So now, two unknown case, if you take the general equation of a two unknown case, the general equation of a two unknown case will be like this. A1x plus B1y equals C1. A2x plus B2y equals C2. So this is the general form of a two unknown system. Right. A1, B1, C1, A2, B2, C2 are given constant. X and Y are the unknowns. Say, for example, we have 2x plus 3y equals 8, 5x minus 2y equals 1. Right. So we want to solve this using the calc. So in your calc, if you are using fx 82, fx 82 doesn't have this facility. Other ones are 100 ms or maybe 991 ES plus or class with any other type as shift option. Right. So you press the mode key. How many of you have seen the silver color ES plus model? ES plus silver color model. Okay, that is class with neither. Yeah. Others are using the black color old ones. Yeah. Right. So press the mode key. In some calculators, 2 times you have to press. In some calculators, you have to press 3 times. So I don't know what type of cal you have. So either press the mode key twice or 3 times. Right? Maybe 2 times or 3 times. Then you will get something called EQN equation. Some calculators once, some calculators 2 times. Not the class width model, right? ES plus class width, that is different. Right? This is for old version. Press the mode key once, sorry, 2 times or maybe 3 times. At some point you get EQN. And above or below, I can't remember, you have 1. And above or below that EQN, you have 1. And then you have to go into that mode. So press 1 now. Press 1. So when you press 1, it is asking for unknowns. Degree or unknowns? Yeah, unknowns, right? Unknowns. Right. Now in this equation, how many unknowns we have? 2. Yeah, you're gonna 2 the 3, the 2 or 3. Right? So we have 2. So now press 2. So now when you press 2, what is it asking? It is asking for A1. That's why I wrote this, right? A1. Right. Now here, first you have to see whether in all the equations, whether the unknowns are appearing in the same order. Right? So, or in all the equations, the unknown should be in the same order. So here, X, Y. Here also, X, Y, no issue. If there is a change, then you have to rearrange, right? In the same order. Right. So now what? This is our A1. This is our B1. This is our C1. This is our A2. Now when there is a minus sign, you take with the sign. So this is our B2. And this is our. So now it is asking for A1. Give the value. 2 equal. Then it will ask for B1. Give 3 equal. Then it will ask for C1. Give 8 equal. Then it will ask for A2. So give 5 equal. Then it will ask for B2. B2 is in your cal, there is a minus key like this. In the functional part, you have a minus key. Subtraction minus name. Our minus in the top part. Right? So that is for negative. This is not subtract 2. This is negative 2. So use this key. Right? Minus what? Minus 2 equal. Then it asks for C. 1 equal. So sometimes when you press 1 equal, it will give you X equals. Equal exam. X equals. Again press the equal key, it will give you Y equal. So in the class width model, press the mode key. Press the mode key once. You get a submenu, series of submenus. Class width, right? So press the mode key. You have a series of submenus. Right. So move on, right? With the oval shape key, move on, right? Move on this way. Somewhere you will get that EQN equation. කට්ටිය වෙන එකක් try එකක් දෙන්න වෙනත් ගානක් 30 follow try එකක් දෙන්න බලන්න dx minus 40 y equals 19 7x plus 3y equals 50 dengan mereka tidak benar waktu terdekat right okay so have you found that equation right and now go into that right press the equal key when the equation is appearing here right when you move on somewhere it will say okay equation so press the equal key right then you get a submenus ax equals b right so the first one is ax plus by equals c right then x y z right ax squared so now this is two unknown case so this is under 1 press 1 now when you press 1 you get a matrix like this you get a matrix like this right so here the cursor will be blinking so at this point what is the value you have to give 2 so 2 equal then it will take 2 here jump on to the next level 3 equal it will take 3 jump on to the next level 8 equal it was then 5 equal minus 2 equal 1 equal like x equals y so here that matrix is for values, right? These 2, 3, 8, 5, minus 2, 1. May values together. And then so we'll go for this example. So when you take down this data set, leave some space on the right side for the calculation. Right? We need that sigma x, sigma y, sigma xy, so we need to get those values. Leave some space on the right. A company has the following data on the last year's sales in each of its regions and the corresponding number of salespersons employed. Develop the least fair regression model. More than one. Mode 1. Mode. So come back to the normal mode. Mode 1 equal. That's how it has to be the mode 1 equal. So now the two equations, right? So to develop the least square regression model, best fit line, overlap the same, right? Best fit line. Now I give you all the names, right? Least square regression line, best fit model, regression model, all is the same thing, right? Okay. So to get that regression model, we have two normal equations. In those normal equations, we have those normal equations we have in terms of x and y. So now here we don't know which one is x, which one is y. So we have to identify. So what are the two things given? Salesperson. So generally think of which one depends on the other. So here, sales depends on number of salesperson. So sales is our y. Salesperson is our x. So now the two models. Normal equation. So what are the two normal equations? First one is sigma. N beta naught plus sigma x beta 1 equals sigma y. First equation. Second equation is sigma x beta naught plus sigma x squared beta naught beta 1 equals sigma xy. So those are the two normal equations. Now in our data set, the region is not necessary. So this is there. First we have the y values. Then we have the x values. Right. What are the other columns we have to develop? Other columns we have to develop. Whatever the sigmas needed, the corresponding column we have to have. So sigma x, so here n needed, n means number of pairs. How many pairs? So here we have 6 pairs. 2, 4, 6 pairs. So n is 6, right? N is 6. Sigma x needed, x column is already there, no problem. Sigma y needed, y is already there, no problem. Sigma x needed, x is already there. Sigma x squared needed, we don't have. So we have to develop that x squared column. Right. Then sigma xy product, sum of product needed, we don't have that. So we develop xy. So two columns we have to develop. So here we have 236, 11. So this is 11 squared 181, so 121. This into that, so come here. Likewise, you get all the individual values and add them. Values are there, the totals are. Those are the individual values that I need to the totals. So we got all the values. We have two equations. So in those equations, we have this stuff. So wherever we want these values, we plug in, we get the two normal equations, we solve, we get our beta naught and now we can generate the values. So the two normal equations we have n beta naught plus sigma x beta 1 equals sigma y, first equation. Second equation is sigma x beta naught sigma x squared beta 1 equals sigma xy. Right. So now what we can do is we can plug in the values. Right. So n, right, n is 6. So n is 6. So we have 6 beta naught. Sigma x is 79, 79 beta 1. Sigma x, so that is 1466. Second one, sigma x, so that is 79 beta naught. Sigma x square 1083 beta 1. Sigma xy 19,730. Two equations, two unknowns. So get your beta naught and beta 1. So when you put this in into a CAD, right? Assume beta naught is your x, beta 1 is your y. And it will give the answer as x and y. So we know x is beta naught, y is beta. So what are the values?
11,603.
Beta naught is 111.
10,03.
111.0. This is 10 point.
10.12.
So now we've got the two values. So these are called the normal equations, right? These are the normal equations. So using the normal equation, we got it. So now what? After getting these ones, now you can write down the model. So what is the model? Y equals beta naught plus beta 1 x plus the. So now you plug in your values. Y equals beta naught 111.03 plus beta 1 is 10.12 x plus that error term. എങ്ങനെ model കിട്ടും? So this is regression model with fit line, whatever. So now we know that what is this x and what this y are. So if you want, you can plug in the real names. So y is state. State equals 111.03 plus 10.12 times x. X is number of salesperson. Number of salesperson plus the. So that shows the relationship between the two variables, how the sales and salesperson are dealing. So that example tells us when we are given a data set, how to develop the normal equation, how to get the two coefficients, the constants, right? And then how to write down the model. Equation model. So I told you there are so many names for this, right? You can call this as regression model, regression line, square regression line, best fit line. So many names are there. So I will just note down those names. Right. So here, regression model, best fit line, least square regression line, least square regression model. All these mean the same thing.
Okay.
So develop the regression model, same question. Best fit find the best fit line, same question. Find the least square regression line, find the least square regression model. All these questions is the same. So that example illustrated how to develop the regression model. So after developing the regression model, always whenever we calculate a measure, we should be able to interpret. Correlation we calculated, then we said, okay, how to interpret that correlation. So when developing this model, we have calculated two values. We have calculated two values, beta naught and beta 1. So we should be able to explain what does this 10.12 means. What does this 111.03 mean? Right? So when you after developing the model, we should be able to interpret beta naught and beta 1. Oh, we should be able to interpret the model. Without interpreting the model, interpreting beta naught and beta 1, same question. Because in this model, you have two values. If they ask you to interpret the model, both values you have to explain. If you are asked to interpret beta naught and beta 1, that is also same question, right? Interpret the model, interpret beta naught and beta 1, same question, right? So next we'll see how to interpret this beta naught and interpreting beta naught and beta 1. What's our topic? Interpreting beta naught and beta 1. Or interpreting the model, same question. Interpreting beta naught and beta 1 or interpreting the model. So we'll take this model and try to interpret. So first we'll go for beta 1. 111.03. Now, let's read for explanation. Now say you have a model like this, y equals 15 plus 3x. You have a model. Don't forget about this model. Suppose your x is 10. X is 10. So when x is 10, what is happening? What is y? Y is 15 plus 30. So y is 45. 45. Now I am going to increase this x by 1 unit. I'm going to increase this x by 1 unit. So if I increase this x by 1 unit, now x becomes, earlier it was 10, 10 plus 1, which will be 11. When x is 11, what is my y value? I want to find out. So 15 plus 33. So it has become 48. Now when I increase, now in this model, when I increase the x by 1 unit, what happens to y? Y has increased. By how much it has increased? By 3 it has increased. So according to this model, this is the beta naught value. Sorry, beta 1 value. Right? Y equals beta naught plus beta 1x. So this is the beta 1 value. So it is plus 3x, so plus 3. When I increase the x by 1 unit, y increases by beta 1. Right? Generalized term, right? Beta 1. Now suppose you have another model like this. Y equals 20 minus 2x. 20 minus 2x. My x is 5. Arbitrarily, I'm choosing a value for x, right? So I'm finding my y value. So y is 20 minus 10, which is 10. I'm increasing y by 1 unit. So my x by 1 unit. So x becomes 6. I want to find my y value. 20 minus 12. So it becomes 8. When in this case, when I increase the x by 1 unit, y decreases. By how much it is decreasing? By 2. From where we get that 2? We have a minus 2. So it increases. When x increases in this case, y decreases. because of this minus. Here, when x increases by 1 unit, y increases by 3, right? So we can generally say, when we increase the x by 1 unit, y changes by beta naught, beta 1. When we increase the x by 1 unit, y changes by beta 1. At plus now, it will increase. If it is minus, it will decrease. So we are saying y changes by beta 1. Positive now increases. Okay, right. So now this is our beta 1. Apply the same idea here. What is the x in our model? Number of salesperson. So when we increase the number of salesperson by 1 unit, this is plus sales, that is why it will increase. It should be 12.9. 12.1. Beta 1. 10.1. Beta 1 is 10.2, right? So now we'll apply the idea. X is number of salesperson. Y is same. When we increase the number of salesperson by 1 unit, beta 1 is positive. So Y will increase, sales will increase. So sales will increase by 10.12, right? So the idea, but when we increase the number of salesperson by 1 unit, by sales will increase by 10.12 units. Right? Okay. So we have applied. Now we can polish this a bit and write up. That will be the interpretation. So here we are saying, when we increase the number of salesperson by 1 unit, that means we are going to use an extra salesperson. Right? We are going to polish color here. We are going to increase the salesperson. So that means we are going to use an extra salesperson. So when we use an extra salesperson, what is going to happen to sales? Sales is going to increase. So we are going to get an extra sales. How much? 10 point. So put that in a nice format. So interpretation. Extra salesperson will generate an extra sales of 10.12 units on average. I'm not saying you have to write it in the same format. Get the idea. Put it in a nice. The idea now, okay, you can write it in a neat form. Fine. Make a generalized second right? When we increase the, what is it? When we increase the x by 1 unit, y will make a change by That's the general one. You got the point? Abhi general like apply karane make it right. When we increase the x by 1 unit, y will change by beta 1. Is the x by 1 unit, y will change by beta unit. So beta 1 is done, right? So the general idea is when we increase the x by 1 unit, y will change by beta 1. So you apply that to your problem related to your x and y, put it in a nice form. Other beta 1. So we take a model y equals, let's say 10 plus 3x. So this is your beta 1, this is your beta node. Right. So now we have to identify a value for x. We have to identify a value for x. When we substitute that x here, y should take the beta 1 value. Right? Beta is beta node, this is beta 1. Right. So we have to identify a value for x. When we substitute that x here, y should take the beta naught value. What is the value we have to substitute for x? 0. So when we put 0, this is gone, y will take the beta 1 value. So that's the idea, right? So the idea is beta 1 naught. And 11.03. So general idea, I write first. When x is 0, y takes the value beta 1 units. If you know the units, you put the units. When x is 0, y takes the value beta. Right, beta. Now we apply the idea. So if we apply, what is it? What is our x number of sales figures? So we'll apply, right? Apply, then we'll put it in nice form. When the number of salesperson, when the number of salesperson is 0, y sales will be 111.03 unit. I will apply. When the number of salesperson is 0, sales will be 111.03. So now we put this in a nice format. So interpretation. When the number of salesperson is 0 means what? When we don't use any salesperson, when we do not use any salesperson. When we do not use any salesperson, sales will be 111.03 units. Unit එක තියෙනවා නම් you put the unit. Say if it is in millions, then you say 111.03 million. So now, if it's possible, we are not using any salesperson, but still we are having a sales, is it practically possible? සමහර වෙලාවට something like say automated kind of right? But most of the cases when we try to interpret this beta naught doesn't have a practical meaning in most of the cases, right? Beta naught doesn't have a practical meaning. Beta 1 will have a practical meaning. Most of the cases, beta naught doesn't have a practical meaning, but you can't remove that. If you remove the beta naught, then the model will no more there, right? Okay, right. So we know how to develop the model, how to get those coefficients, and how to interpret those coefficients. So the important thing is when you interpret idea, you apply the idea, then you put it in a form. Next. Forecasting. So the purpose of this model is forecasting. So why we develop this model? We develop this model for forecasting. Forecasting. So you develop the model, you interpret the model, you forecast. So underneath you can note down this way. Once the equation of the regression line has been computed, it is straightforward process to obtain forecasts. So example for that. Considering the previous example, forecast the number of sales, that would be expected, next year, in regions that employ 2 parts are there. 14 salespeople or salesperson, 25 salespeople. 14 salesperson, 25. So we have the model. So using the model, to substitute and check the value. So we have the model. Y equals 111.03 plus 10.12 x plus the error term. Right. When you forecast, you drop that error term and forecast. You assume that error is 0. Right. Okay, so first part, substitute. Y equals 111.03 plus 10.12 times x. So x is 40. So we drop this epsilon. So you got the calculator, so you can simplify. So that will be the forecasted value. Then second part, same way. Y equals 111.03 plus 10.12 times 25. Forecasted. You are finding the value of y or response variable when the predictor variable is given. So now here, when we forecast, right, so we are saying right through our model, we are saying right, okay, if you use 14 sales people, your sales will be this much, right? So when you forecast, you should be able to say how much you are sure of that forecast, right? We can't go for 100% perfect forecast. Maximum 99.99% you can go, but not 100%. So whenever you are giving a forecasted value, you should be able to identify the validity of that forecast, how much you are sure of that forecast. So we are saying, okay, what is the value of this one? 252. Okay, so 250. So if you use 14 sales people, your sales will be 252. So how much you are sure of that value? The validity, right? So whenever you forecast, you should be able to say what your validity is. Next. Validity of the judging the validity of forecast. Okay, so it's a process sort of a thing, right? Data set given, you develop the model, you interpret the model, and then you forecast a value, then you are judging the validity of the forecast. Judging the validity of forecast. Judging the validity of forecast. So validity of the forecast is given by the coefficient of determination 100 R square. So 100 R square, the last week we discussed 100 for the coefficient of determination. So the coefficient of determination gives us the validity of the forecast. Validity of the 100 R square. R is the correlation coefficient, right? Take so example you take, right? Identify example, identify the validity of your forecast. Identify the validity of your forecast. Example, identify the validity of your forecast in the previous example. identify the validity of forecast of validity of your forecast in the previous example. The previous example, right? So for that data set, we didn't calculate the R value. So R value for that data set is 0.9. This is the value. Right, for that data set, we didn't calculate it. Straight away, we found the regression model. So this is the R value, 948. R equals 0.94. Right. So now what we want to calculate is 100 R square. 100 R. Validity equals 100 R square. So 100 into 0.948 per. So you can evaluate this up to 1 decimal place. 89.1. 89.7. 87. So we'll go up to 1 decimal place. So 89.9%. So we are almost 90% sure of the forecast. So that means there is a 10% chance that we may go wrong. Okay. Okay. So all the process we have covered, right? For a simple regression model. Develop the model, interpret the model, forecast, validity of the. So we go for a complete example. Whatever the stuff we have discussed is covered through this session. So data set is here. When you take down the data set, make sure to leave space on the right side. We need to develop some points. A company has the following data on its profits and advertising expenditure over the last 6 years. First part, identify the predictor and the response variable. Find the correlation coefficient and interpret. Find the best fit line. Interpret your best fit line. Forecast the profit. If the next year advertising budget is 800,000, what is the validity of it? predictor variable, response variable. So, advertising expenditure, profit. Generally think of and identify which one depends the other. Profit depends on and so predictor is advertising expenditure. Response is profit. So this is your Y. This is your X. Predictor response. Then first part, they are asking us to calculate the correlation. The correlation to formula is there, so you can use whatever the one you feel easy. The second one is easy actually. So the formula R equals N sigma xy minus sigma x sigma y over N sigma x squared minus sigma x squared N sigma y squared minus sigma y. Don't forget the big square root at the other part. So this is the formula we are going to use. So whatever the sigmas needed, the corresponding column we have to have. So at the moment we have y and x. Y. So what are the other columns we need? Sigma xy needed. So xy column we have to develop. Sigma x needed, x is there. Sigma y needed, y is there. Sigma x squared needed, we don't have, so I will generate squared. Sigma x whole squared, x needed, x is there. Sigma y squared needed, we don't have, so y squared. Sigma y whole squared, y needed, y squared. So three columns we have picked up. xy, x squared, x squared. So since all these values are given in millions, without rounding off, when you square this, it should go up to 2 decimal place. When you square this, it should go up 4 decimal place. When you multiply these two, it should go up to 3 decimal place. Because 2, 1, 3. Around 100, because there will be a huge heat because everything is in millions. The formula is there. We have calculated the values. So plug in the values, n is 6, how many pairs, tuples, how many pairs, 6 pairs, then 6. Sigma xy 54.3, then sigma x 3.91, sigma y 86.4 over 2 pieces, n the 6, sigma x square 2.59, 58.9, 3.19 square sigma x 46 square. 6 sigma y here, sigma y square, so minus sigma y 46. So you simplify, you get 93. 9355 or something again, so 3 days. 36. So after getting the value, then we can say, okay, what type of relationship is there? It shows that there is a very strong positive linear relationship between advertising expenditure and profits. Shows that there is a very strong positive linear relationship between advertising expenditure and okay. So after getting this value, you transfer this to two decimal place, 0.94, then in your scale, you see in what region that value falls to. So that falls in the very strong positive region. That shows that there is a positive, strong positive linear relationship between what and what we are talking about, advertising expenditure and a second part, we calculated, interpret. Third one, they are asking us to develop the best fit line regression model, all these the same. So model we have. So first we have to develop the normal equation. normal equations. Then beta naught plus sigma x beta 1 equals sigma y, first equation. Then sigma x beta naught sigma x squared beta 1 equals sigma xy. Second equation. So now we have to substitute and get the two equations. N is 6. So 6 beta naught sigma x, so 3.91 beta 1 sigma y, so that is 82.4. One equation. Second one sigma x, so 3.91 beta naught x squared, 2.5819 beta 1 sigma xy, so that is 54.33. Two equations, two unknowns, and get the values. Beta naught and beta 1. Normal equations. Then you substitute the corresponding values. Get your beta naught and beta 1. The third part, I forgot to put the number. The third part. Yeah. Beta naught is some 1.5. The one is 18.5. 565. 654. 1.65. 5.56.
6.5.
0.65, right?
6.5.
5 also, okay, so this should be 5 then. Is 18.672. And so better to go up to the 3 decimal place because all the values are in millions. So even if there is a small rounding of error, then that will create a huge hit, right? You go up 3 decimal. Right. So now the two values identified, we can now write down the model. So what is our model? Equals beta naught plus beta 1x plus the error term. So y equals beta naught, we have found 1.565 plus 18.672 times x plus the error term. So we know the real name. So if we want, we can use the real names also. So this is profit. So profit equals 1.565, 18.672. X is advertising expenditure. I just write ADB advertising expenditure, plus the right. So third part, they are asking us just to develop the model. The fourth part, interpret the model. Third part, find the best fit line, right? Fourth part, interpret the best fit line. So we'll interpret. So first we'll interpret beta 1. So beta 1 is 18.672. So what is it? Right, we'll apply the idea. When we increase the x by 1 unit, y will change by beta 1. When we increase the x by 1 unit, y will change by beta 1. So here it is plus, so y will increase, right? So if we increase the advertising expenditure by 1 unit, so what is the unit? Million. So if we increase the advertising expenditure by 1 million, profit plus, so profit will increase by 18.672 unit. Again, y unit is millions, right? So if we increase the advertising expenditure by 1 unit or 1 million, profit will increase by 18.672 million. So we are going to spend more, we are going to get spent. So extra things. So an extra million on advertising, an extra million on advertising will generate an extra profit of 18.672 millions. That's the explanation, right? Apply, put it in a nice form, right? So when we increase the advertising expenditure by 1 million, profit will increase by 18.672 million. So an extra million on advertising will generate an extra profit of 18.672 million on average. Okay. Right. I'm not saying you have to put it in the same format, right? Get the idea, put it in a nice way, right? Right? So put it in a nice way, right? That's all. Idea valid, that's fine. That's all you need. So, an extra million on advertising will generate an extra profit of 18.672 million pounds on average. So beta 1 is done. And what? Beta naught 1.565. Okay, apply the ID. When x is 0, y will take beta naught. When x is 0, y will take beta naught. So x is advertising. So when the advertising expenditure is 0, when the advertising expenditure is 0, profit will be 1.565. Advertising expenditure 0 means what? We are not spending anything on advertising. When we don't spend anything on advertising, profit will be 1.565 million. When we don't spend nothing, when nothing is spent on advertising, right? When nothing is spent on advertising, profit will be 1.565 million pounds. Take a data, if you include on average, it's okay, fine. So why we say on average, now see, if you spend 1 million on a particular year, you don't get exactly 18.67. Right? සමහරවිට මේකට වඩා වැඩි වෙන්න පුළුවන්. සමහරවිට මේකට වඩා අඩු වෙන්නත් පුළුවන්. But ඔය වගේ 1 million extra spend කර ගිහිල්ලා ඔක්කොම average ගත්තාම right, that average would come to this. You got the point? හරි. අවුරුද්දක මේ කියන්න බෑ මේ අවුරුද්දේ 1 million ධම්මනවට අනිවාර්යෙන් මේක එනවයි කියන එක නෙවෙයි කියන්නේ. Right? On average, right? ඔය වගේ කරගෙන ගියාම on average you get this value. Sometimes it may be bit more than that, sometimes it may be bit less than. So we have interpreted the next. They are asking for a forecast. The next one, fourth one. Forecast the profit for the next year if an advertising budget of 800,000 is allocated. Right. So we have the model. Advertising budget is given. If the advertising budget is 800,000, what would be the profit? So our model is profit equals 1.565 plus, so this is the fifth part. 1.565, 18.672 into advertising expenditure plus the error. So now we have to substitute. So when you substitute, they have given 800,000. So 800,000 we don't substitute as it is. We have to be careful about the unit. When developing this model for advertising expenditure, we use the values in millions. So with the model is developed in terms of millions. So when you substitute also, you have to substitute in millions. So 800,000 you convert into millions, 0.8 should be substituted. So 1.565 18.672 into 0.8, right? So you evaluate, you get that many, whatever, million pounds. So finally, now we have given a forecasted value are getting some 16 or something. 15 point something. So you have given a forecasted value. The last part they are asking, what is your validity of that? The last part, validity. Six part. Validity of the forecast. 100 R square. So 100 into 0.936 to the power of 2. So you can evaluate up to 1 decimal place, point, whatever, right? That 20% you are sure. 87.6. So there is a 12.4% chance of being lost. Okay. So that covers the full thing up to one simple regression. So ඊළඟට කතා කරන්න තියෙන්නේ multiple regression. අද